So this is what I saw on your papers. So you guys copied those graphs, great. So let's talk about these asymptotes. We see a little bit, okay, I'm gonna draw an imaginary line right here. So it's not part of the graph, it's just my imaginary line of where I feel like these lines are approaching. Do you agree that they're approaching right there? So what is the equation of that imaginary line? X equals 4. So that's your vertical asymptote. Because it's going up and down, right? Okay, and then I'm looking over here and I see that they're approaching this line as they become horizontal. What is the equation of that line? Y equals 0. Right here, they're approaching this line. What was the equation of that line? It's okay, don't be shy. I'm nice. Speak loud. Okay, and then they're approaching this line. What was that line? Y equals 0. This one had two lines that it was approaching vertically, right? What were those two lines? X equals what? -3. And x equals 1. And then it also was approaching these on the ends, which we all agreed that was y equals 0. Okay, I want you to look at something. What are the excluded values of x in these three functions? So these are the same functions that we graphed. What are their excluded values for this one? 4. This one? -5. This one? How would you find that if you weren't looking at a graph?
It's the vertical average. Well, so if you were to factor.
Not look. Yeah, factor it.
Factors, and then you set it equal to 0, and then x is equal to -3.
Yes. So this one we would factor, and then we have our excluded values. So how are, I mean, this is kind of repeating. How are our excluded values related to our asymptotes? Let's look here. Here's our vertical asymptotes. Here's our horizontal. Here's our excluded values. How are our excluded values related to our asymptotes? Hey. Thank you. How are excluded values related to our asymptotes? They are the vertical asymptotes. Vertical. And then, I don't like that question. It's kind of obvious. What are happening to the y values as they get to the asymptote? But no touchy. In your own words, describe a vertical asymptote and how you will find where it will be. Okay, I'm not going to call on anyone, but I want you to raise your hand if you understand where to find vertical asymptotes. We'll not move on until every hand is in the air.
Just making people put up their hand if they don't understand.
I mean, I feel like you are all answering this. Where do you find your vertical asymptotes? Looking at the last 3 questions, okay. Fair. Not using your graph, just looking at your equation.
Right, the table.
Let's look here. Find the excluded values. What were our excluded values?
-5. -3 and 1.
Okay, what were our vertical asymptotes?
4, -5.
Oh, good. Yeah, I'm so glad you caught up.
Oh.
Yeah,
Carter
okay.
said,
Huh?
Carter said denominator, is that what you want?
No.
Oh, okay.
No, we were at like, oh, our vertical asymptotes are excluded values.
Hooray!
Excluded values. Okay, so let's predict from this, where are the vertical asymptotes for y equals x minus 1 over x? Somebody raise your hand. Somebody other than Kaden, raise your hand. Yes. At 0.
Nailed it.
X equals
Nailed it,
0.
first try. Woo!
So let's draw our little dotted line there. That was so pretty. What's another word for x-intercepts?
Where it crosses the x-axis.
Where it crosses the x-axis. Good. How do we find them algebraically?
We solve for x.
Solve for x when y equals? Yeah, good. Yes, so we
Zero, fruit solutions.
y equals 0.
Maybe you need to make vocab cards.
Didn't Buse say she was going to do that vocab for this lesson?
Yeah, but she's nicer than me. I told them they should make their own.
Oh, yeah. Write these down.
If she makes it, I'll still share it. I just won't make it.
Maybe. Okay, so do that.
I know.
0 equals x minus 1 over x. How do we solve for x? First step. Multiply by x. Okay, I want you to notice something. Since this is a 0, I multiply by this x. What happens to that x?
It's just 0.
It's just 0. It's almost like it disappears. So this is going to be a shortcut for every time you're working with rational equations. Finding your x-intercept, you set the numerator equal to 0. So you could skip that multiplying by the denominator step. X equals 1. So that is our intercept. Right here.
Absolutely. Is there a puppy in that one again?
I would. We all should. Everyone bring your pet to class next.
Anything but a backpack day.
Yeah.
I brought my cat last year.
I love that, like, people know that. I'm not a TikTok
They did
follower.
it last year.
There was multiple lawnmowers. People brought their shingles and chill. It should be fine.
Okay, so how do we find our y-intercepts algebraically? If we set y equal to 0 for x-intercepts, how are we going to find our y-intercepts? Set x equal to 0, so y equals 0 minus 1 over 0. Wait a second, what is that?
They brought their siblings. It was funny.
Error. It doesn't cross the y-axis. This is undefined. Wait, that kind of makes sense though, right? What was my vertical asymptote? X equals 0, so that means
Because x is 0 because it's in x. And then on the top, it's just, because the top is the horizontal asymptote and the bottom is the vertical asymptote.
Yes.
close.
Sister?
Wait, okay.
Wait, did you just say undefined is for calculating the y-intercept algebraically? Is that what that arrow is?
When x equals 0, this is undefined.
Oh, for this specific problem, but not as a general rule. Got it.
Yeah, no, it,
I agree.
no.
Yeah, that's right.
Okay. All right, so I need you to somebody graph it on your calculator real quick.
Guys, bring it back.
When you graph it on your calculator, come up here and draw it on my screen. Let's see.
That's terrifying.
Who has a calculator?
Almost
Okay, Daniel, when you're done graphing that on your calculator, come draw it up here. It's the x minus 1 over x is your equation. He was like,
I don't know how to work Isaac's calculator.
I know, it's okay.
I need
He
help.
can help you and then you can draw it.
okay,
I should.
it's fair.
Sorry, I was just trying to figure it out.
I did the numerator thing wrong. What do you call it? There's nothing on my screen.
Anyone think this one is gonna have a horizontal asymptote again?
This is Isaac's graph.
It doesn't.
On my tablet.
Oh, okay.
And by mine, Summers.
It doesn't.
And by summers, you mean the schools.
Hold up.
Slash my daughter's, because she colors on it every night.
How did you get that? Because my screen is.
This is gonna be rough, but I'm gonna try.
I thought you were supposed to put
Basically, like,
How did you get it to look like that?
see it. Why did you get it? Oh, we're typing that in.
that, and then it's like,
Because, so, look, your
Something like that.
asymptote is
I
positive.
think that's pretty close.
It's
Yeah,
so
okay. Thank you.
No, it does. Because it's the top. The top is horizontal.
Oh, no, wait.
Da da da. All right. So yeah, on your calculators, it approached x equals 0, and there was an intercept at x equals 1. No, 1, 0. And I'm also noticing this vertical, nope, horizontal asymptote here. So we'll write that. What is that horizontal asymptote? What is the equation of that line? Thank you. Y. Y equals 1.
She got the same thing as me.
Well, that's good. Wait, is it good or was it wrong?
What?
Oh, sorry.
Okay, let's move on.
Well, there's an X on top and a bottom. It's
It's just one.
that doesn't work on the other one, so it's like X minus 5, right? That's not.
Sorry, do you agree to move on to the horizontal now?
Do you want me to do it or do you want to do it?
I'll try, and then if I'm struggling. Okay, so I think we all agree we can find the vertical asymptotes just fine, because you guys know how to find excluded values. Where do we find our excluded values? The denominator, exactly. We set it equal to 0. We factor the denominator, we set it equal to 0. That's how we find our vertical asymptotes. I feel like you all get that, so I'm going to move on. Let's talk about horizontal asymptotes. Yeah, we did. We're going to go down to the bottom of page 14 where it says horizontal or end behavioral
It's
asymptotes.
squared. It's squared. That's why it's. What?
Where are you at?
Past you.
Oh, are you at the horizontal or end behavioral asymptotes on page 14? Yeah. We're skipping because you guys get it. I trust you. Yeah.
On the ones above that where it's in factored form on the numerator, do we have to factor it out before we solve it?
Where does it say the factored form on the numerator?
Like above, it's on 14, number 4. It's like the 3 ABC questions.
Oh, it's in. No, so we just factored the denominator when we were looking for the vertical asymptotes. Good question. Okay, so the horizontal asymptotes appear on the graph of some rational functions. These are called end behavioral asymptotes. So the horizontal asymptotes talk about the end behaviors of your graph as they go this way. Okay? Yep. So I want you to graph this equation on your calculator. Y equals 2x over x plus 1. Okay, so what was the degree of the numerator? 1.
That's what she's having to do is compare the graph. Right?
What is the degree of the denominator?
1.
1. On your calculators, where is the horizontal asymptote? Where are your end behaviors approaching?
1.
Use your trace button.
Use your trace button. Go to the line, see where it's approaching.
Start using your
So-
left and right arrow.
I clicked trace. And then I'm going to go to the right. Going to the right. Oh, it looks like my Y is getting very close to what number? Nope, round up. 2, good job.
It's because the top. It's a scalar of 2?
Your horizontal asymptote was
2.
Y equals 2. Yes.
So if the vertical asymptote is like with the numerator, it's just one. So I mean, no.
Wait, hold on. You talk louder. Everyone else zip it. Everyone else zip it. Talk louder.
So since the vertical asymptote or whatever is the denominator, is the horizontal one just the numerator?
So that was a very good observation. We're going to keep looking at these to see,
But
right?
Why are
Because
you
it's
guessing the numerator? What about the numerator made you guess that? Okay, keep that in mind. Okay?
what's the degree of this equation? Numerator 1. Denominator. What do you think the horizontal is? And graph it.
7.
We're going to graph it.
Miss Cooper,
Yes.
will you change C
Yeah.
to 3x minus 2 on the bottom? No, just leave it.
Oh.
Just add a. You guys, I want you to all make this change. Make it 3x minus 2 on the bottom. And then try. And then it'll help the pattern come up better. Okay?
Negative 1. Right?
Yeah.
'Cause you have to
Do that one instead. You'll see the pattern better.
This was our 7x plus 4. I agree that asymptote was at 7, like you said. Now plug in, like you said, the y equals negative 3x plus 1 over 3x minus 2.
Yeah, all I did is add a 3 to the coefficient on the bottom of the thing. It'll help you see the pattern better.
We should probably graph.
basically, it's the top x divided by the bottom x.
It's not negative 1.
Negative 3 divided by 3 is negative 1.
On your calculator.
I know, it's negative 3.
That's, yeah, so just looking at your calculator.
It's because it's a.
Okay. Now that you've graphed it, what did you find? What was the horizontal asymptote of that one? Negative 1. Wait. It's not negative 1. It's, what's the equation? Y equals negative 1. I confused you. I scared you. But you're going to remember your horizontal asymptote has to be in the form y equals. Oh, that's good. Yeah, good job. Okay.
Why is there negative 1? Why is it not regular 1?
On your graph, you'll see that it's down below the x-axis. So that's where the negative 1 is.
Oh, this one, not this one. Okay, makes sense. Never mind.
Yay!
But it's a horizontal.
This is a horizontal asymptote. Okay, so what is the pattern? What are you seeing? What was your name again? I feel so, no, you, in front of Kaden. You. No, what's your name? I just want to know your name. Jacob. Okay. I want you to tell the class what you found out. Okay, we're gonna listen to Jacob. He figured out a pattern.
Alright, so basically if you plug in like infinity, or I like to do 1,000 for any of these graphs, right? So for the first one, 2 times 1,000 is what? 2,000, and the bottom would be 1,001. But the 1 doesn't really do anything, so the horizontal asymptote is basically at 2. And then the next one, 7 times 1,000 is 7,000, divided by 1,000 is 7. And then the next one, same thing. So you only really have to worry about what affects x. You don't really have to worry about like the tiny like +1 or -2. Because that doesn't really do anything in like the grand like scheme of the graph.
Which is why these are called end behavior asymptotes, because
Yes.
you're looking at the ends. That's perfect.
That's awesome. Okay, so what he said, it's what's affecting the x. So right over here, it was a 2x and a 1x. So that's, what is that called, the number affecting the x?
Okay, okay.
Vocab.
Sorry, what?
What? Coefficient.
Ah, be brave.
The coefficient of your leading.
Coefficient.
Yeah, the leading coefficient. Sorry. So take the leading coefficients. This one was 7/1. -3/3 gives you. So do you see that? Yay! Okay, let's look at these ones though. These ones look a little bit different. What do you, okay. Remember, we're looking at the degree of the numerator and the degree of the denominator, and then we looked at what the horizontal asymptote was. So here, what is the degree of this numerator? The numerator. 1. And then the denominator. 2. Now graph it. Find your horizontal asymptote.
If the same pattern above holds true, where should the asymptote be? If the same pattern above holds true, where would the asymptote be? 1, right? If it's the same pattern. But graph it and see. Aiden, Dad, and Shannon, focus. Kevin was gone last time, so he's got catching up to do. Well, I would do the same.
Okay, remember, your horizontal asymptote has to do with your end behaviors.
8 this week.
Okay, so look at the end, left and right behaviors of this graph. What is the horizontal asymptote? Did you find it?
Is it 1?
Look at your graph. Look at your graph.
It is 0. That's what we're trying to bring up. It's not the same pattern as last time, so we got to see what's different in the equation.
1,000.
We're looking at horizontal asymptotes, not vertical. Horizontal asymptotes.
Are my questions bothering you, Cooper?
Absolutely
This is
not.
like one of my favorite things to teach.
Yeah.
I love teaching this stuff.
We're just a team. It's okay.
And I won't get to teach it all year
This
now.
makes actually a lot of sense.
Well, good. Explain it to your neighbors.
So good. What is the degree of this numerator? This one, denominator, 3. What do you think the, oh, guys, I made a mistake. What mistake did I make? Thank you. Oh, look at you guys. What do you think the asymptote of this one will be?
0.
0. Why?
1,000 times 1,000 times 1,000 is what we can do 1,000.
Ooh. That was so good.
Jacob is nailing this today. Hold
He's
on, let's help everyone else
Yeah.
understand why that makes
I want you to
perfect
do
sense.
this.
You want me to do it?
I want you to do this because you were doing it really well. yesterday.
Because this is my favorite thing to teach. I can't even contain myself, okay? So hold on. When Jacob was saying earlier on these last ones, okay? When Jacob was saying earlier on these last ones, like the +1 doesn't matter as x gets huge, because these behavior asymptotes, they're not math error, like a divide by zero error. We see them as what's happening on the graph as the ends, right? So when he was saying the +1 doesn't matter, it's because these are kind of like growing at the same rate, right? As x becomes huge, what's a bajillion +1? How different is that than a bajillion? Not much, right? So like, that's why, because these are technically like at the same rate, because the degrees are the same. You with me? Right? Now let's look at this one. Jacob just said that 1,000 over 1,000 times 1,000 times 1,000. Hold on. What is he trying to visualize? Someone else tell me. What is he trying to visualize? Huh? Something far from zero on the bottom.
And something close on top.
And something much closer on top. Do you see how the rate of this one, the cubic, it grows so much faster? You with me? Now hold on. I want you to look at... Okay, let's say I have some fractions here. Okay, 1/2. 2/10. Did both the numerator and denominator grow? Yeah, right? Okay, and don't steal my thunder. Up here. Okay?
So well.
Stealing my thunder. Okay? Did both the numerator and denominator grow?
Yes.
Okay? Did both the numerator and denominator grow?
Yes.
Which one is faster?
The bottom.
The bottom one, right?
And that basically goes zero.
That's a lot bigger.
Which one of these fractions is closer to zero?
Top.
Right? 10 divided by 100 million
Is
is a lot closer to zero than this, right?
That's why you plug in big numbers.
So the idea is that if here my denominator grows at a faster rate, right? So how can I quickly, the horizontal asymptote is automatically at y equals 0. It doesn't matter what the coefficients are, right? So we've got our two patterns. The degrees are the same. You divide the coefficients. Someone raise your hand and tell me what this other pattern is. How do I know? Someone raise your hand. Is it if they're different? Careful. What would happen if I switched these?
it'd be far away from zero. It'd be quite large. Too large, I think.
Does this number approach 0?
No.
Is there a number this is getting closer to?
Yes.
Infinity. But infinity's not a number, right? So it's not, you're right there. It's not that if they're different, right? What is it? If the denominator is larger degree, then it's automatically the horizontal asymptote at y equals 0. Yeah.
If the numerator has like an extra degree than the denominator, so that means there's no horizontal asymptote.
Correct. I want you to come down here, and this right here, at the bottom of this page, is what all this is saying. If m is less than n, okay, the numerator is m. It might help. This is just at the bottom of this page. Then it's if m is less than n, so that means the denominator is bigger. Automatically y equals 0. If the if the numerator is bigger, then just like what Jake said, there's no horizontal asymptote because there's just no number. So you just write the word none if it asks.
I see.
And then you divide the coefficient there. Yeah.
So like on C and 2C, if it was like -26 to the fifth, have no horizontal asymptote.
On which one? 2C? You're right. If this had a 5 here, then we would have said none. You got it. You got it? Do you want me to finish up the last part because I'm up here, or okay? What are points of discontinuity?
What's the hell right up?
What's our vocab word for points of discontinuity? Let me give you a hint. It's the word you forget to. Oh, there you go. Excluded values.
That's right.
Yeah.
Guess word.
What is an asymptote?
Excluded values.
Try again. That's vertical asymptote. Boundary lines or graph shapers, like Spanx for graphs. They shape the graph.
I did not need that. Thank you.
You're welcome.
That's outrageous. It's very good analogy.
She's so good with real world.
With real world comparisons. What is the difference between horizontal and vertical? This one is found by a math error. And this one's found by the end behavior. How do you find vertical? Set denominator equal to 0. How do you find horizontal? You can think about it like plugging in large numbers and then comparing the degree of numerator and denominator. My handwriting sucks. If you need more than that, don't forget that this page right here puts all of the horizontal asymptote rules for you, right? Okay. How do you find x-intercepts? What's the rule?
Set y to 0.
How do you find y-intercepts? Set x to 0. What is domain? What's domain? It's not all real numbers because we've got excluded values.
All possible.
Value, x values. Remember, domain x is range y's. We did it. You did it. Does anyone have any questions? Okay, there you go.